This is Kelvin with Control by Web, and I'm here with Shaw Merrill with Automation Products Group. And today we're going to talk about level measurement and control. We're going to talk everything from the instrumentation side, the sensor side, all the way to the controller and what you do with that signal. And we're going to cover specifically ultrasonic level sensors today. So Shaw's our expert. He comes with APG, Automation Products Group. They've been manufacturing ultrasonic level sensors and other sensor technologies since the 80s.
Since the 80s. It's been a long time.
Yeah, a little over 30 years. Shaw's been there the entire time. He's the guy.
Close to. Close to.
But they've been manufacturing ultrasonic level sensors and other technologies over 30 years here in the USA. Build to order.
Yep.
Help the
custom products. We have some off the shelf, but most of them are custom ordered to what they want.
Yeah. So they're going to match the sensor technology to your needs. Today we're just going to talk about one of the technologies they manufacture, which is ultrasonic. And then we'll also talk about how Control by Web controllers take that signal and turn it into conditional logic, turn it into remote alarms, notifications, all the things you want out of a controller, especially in the modern IoT age. So yeah, Shaw, take it away. Tell us about ultrasonic sensors. And
yeah, I think on the ultrasonics, you want to start with the basics, right? And kind of how they operate and what they are. So an ultrasonic sensor uses sound waves, right, to measure distance, to measure levels. You can do presence detection as well with those. So basically what's happening is it's sending a sound wave from the face of the sensor out to the surface of whatever you're measuring. So if you're in a water tank, for example, it'll send that sound wave out to the surface of the water, bounces off of that surface of the water back to the sensor to get its reading, and then it calculates that in time to give you your level reading or your distance reading. So that's the basic principle of how the ultrasonic works. We then take that, calculate the distance reading, and then give it an output. It either goes in an output like a 4 to 20 milliamps signal or a Modbus output that then you guys can take and use in your control devices. So one of the advantages of an ultrasonic sensor in a lot of different applications, whether it be in a water tank, whether it be chemical, in water, wastewater applications, is it's a non-contact, what we would refer to as a non-contact type of sensor or technology, because the sensor doesn't actually come in contact with the medium that you're measuring. We're using the sound waves to contact that and measure the distance or measure that level reading. And so you're not actually coming in contact, which is an advantage because there's a lot of people who don't want that in contact, especially if they're using potable water, drinking water.
So you've got to worry about contamination.
You don't want it touching that.
Yeah, there's other liquids that are very sticky, right, that will actually build up on your sensor and kind of mess that up. So that's a big deal.
So you got to be careful with that non-contact. Another big advantage of ultrasonic sensors is they're an inexpensive sensor compared to some of the other ones that you'll find out there for measuring level and distance. For $400 or $500, you can get a sensor for measuring your tank, whatever you're wanting to measure. Combine that with your controllers, and you're under $1,000 for an application, which is phenomenal price. Great value for the technology that you're getting. Another advantage is the accuracy that you get with an ultrasonic sensor. It may not be as fine accuracy as some other technologies that are out there, but for an ultrasonic, you're looking at 0.25% of the detected range. We won't get into detail of that, but it's very fine accuracy, which is really good.
Most applications, that's plenty, right?
More than what you need.
Yeah.
A lot of people are only looking for maybe 1% or 2% of accuracy, and so you get below that 1%, and you're talking very accurate, very good readings for whatever your application may be. As far as installation of your ultrasonic sensors, they're very straightforward, very simple. All of our ultrasonics either come with a 2-inch, what's called an NPT thread, or a 3-inch NPT thread. You can get a little bit smaller if you need as well, but it just installs it right on top of your tank or whatever your application is. You wire it up to your controller, and the simple part of it is it's basically plug and play. You can wire up that sensor, you've got it installed in your tank, and you're ready to go. If you want to fine-tune that sensor to your application, let's say you want to change your max distance reading, or you want to, there's several sensors within the ultrasonic that then you can go in and you can fine-tune and really dial it in, kind of like you are on a radio. You know, you're dialing in that, tuning in that station really clear. If you want to really fine tune the sensor, we can get into that and you can do that. But at its surface level, all of our ultrasonics are really plug and play. You just plug them in and they're ready to go.
And they work. And there's a couple things to keep in mind, right? You've got to protect that sound, wave, make sure it's not going to hit on something it doesn't want to. What is your angle as it comes down from the sensor? Yeah,
our sensors have a 9-degree angle, which means from the face of the sensor, it goes out 9 degrees. So the further you get away from the sensor, the sound waves get wider in that tank. And so some of the things you want to take into account when you're looking at an ultrasonic sensor are the environment that it's going into. Do you have vapors or do you have foam? Things like that. Some of those are not really great with ultrasonics because they'll bounce off of the foam or bounce off of the vapor,
and that's
versus
where
you get false readings. And then you can get into other sensors like a submersible pressure transducer or radar sensor or things like that. You want to look at your tank that you're going in and make sure that your tank has smooth sides on it so that it's not bouncing off of different levels in the tank on your levels as well. And you want to make sure that sensor is installed in the right place in the top of the tank. You don't want it right in the middle, but you don't want it right on the edge next to the wall either, for fear of getting some of those sound waves bouncing off of anything that may be on the side of that tank.
Yeah, because it's really a sensitive device. It's going to pick up on a lot of things. Yeah. But you guys have a lot of installation tips and tricks to bypass a lot of that too.
And we have all those on our website. You can go on and find videos on how to install it, how to fine-tune them if you want to do that with some of the programming software. All the things you want to look at as far as the installation and the conditions that you want to look at. So we've gone through what an ultrasonic is, some of the advantages of ultrasonic, the ease of installation and the ease of use of these sensors. There's a lot of different applications that they can be used in fact, a plethora of applications. We see them a lot in the water and wastewater markets where people are using them in water tanks, they're using them in sewer applications on underneath sewer lids. Okay. And they're monitoring stormwater, a surge, things like that with ultrasonics. They're used a lot in the car wash industry, actually. It's an interesting one. So, if you've gone through an automatic car wash, oftentimes they're using ultrasonics to judge where your car is, to kind of do a profile if you're dealing with a sedan versus a pickup. So there's a lot of different applications where ultrasonics are used because of the advantages they have, because they're inexpensive, because they're easy to install and program, and because they're accurate sensors. Those three things are probably the biggest selling points of ultrasonics.
So it makes them like a really good general purpose level measurement or even distance measurement.
And you can get them in like we said earlier, in the different outputs. If you just want a simple 4-to-20 device, we can do that. If you want a Modbus, we can do that. If you want other outputs, there's other outputs that we offer as well on the ultrasonics.
So if there were 3 things that I need to remember about ultrasonic, what would those be?
Ooh, that's a really good question. 3 things to remember about ultrasonic is your environment. You want to know what it's going into so that you know that if it's the right technology to use. You want to know what your distance is of what you're measuring. So if you're going into a tank, how tall is that tank? Is it 10 feet? Is it 25 feet? Because that will help you determine, okay, which sensor do I need, because they're offered in different lengths that you can measure.
What would be a maximum?
Our sensors go up to about 50 feet max. Common is 25 feet.
Yeah.
As short as 9 inches.
Okay.
Anywhere from 9 inches up to 50 feet on the ultrasonic sensors. A third thing you want to think about with an ultrasonic is your budget. How much do you want to spend on your sensor? How much do you have to spend on your application? If you want to go budget friendly, ultrasonic is definitely the way to go.
Yeah, ultrasonics are really, really cool, and they're all over the place. It's, when we think about the industrial world, we're often talking about things that are really invisible to the layperson, people who are just driving by and walking by on a day-to-day basis. But ultrasonic sensors they're a backbone of level measurement technology. So once you have an accurate sensor, now what? What do you do with that signal? And as Shaw mentioned, you have a 4-to-20 milliamp. That's one of the most common sensor outputs. A continuous sensor output in the industry, period, across a variety of different sensor technologies. You also have the Modbus RS-45, which is very common still. And so when you take those signals and you want to do something with them, you want to make a logical decision based on what that signal says. You want to log that signal. You want to send it up to a cloud platform, an IoT platform, or a SCADA. So that's where the sensor it needs help with a controller, and that's the controller role. Here are two controllers that we make, control by web manufacturers. We have our X404, and this is a Modbus RS-45 input device. And then we have an X412, and this is one of our most popular 4 to 20 milliamp or other analog 0 to 10 volt, or some of those analog signals input device, very common. And this one also has embedded relays, four relays on the device. And so these two devices are very commonly paired with ultrasonic level sensors, those from APG specifically. And these devices they're edge logic controllers. And what the edge really means is where the source of data is. This is the sensor and the machine level or layer in industry, in the control system map, if you will. At the sensor data, at the source of data, at the sensor level is where the edge is. And so we provide the edge controller. It's going to connect directly to the sensor. It's going to receive its signal, and then it's going to process that somehow. So I can use, with a control by web device, they're going to speak a couple different protocols. Modbus TCP/IP is the old ubiquitous protocol. It's kind of everywhere. It's getting older. It's still very useful. It's still very widely used. But then there's a more modern protocol called MQTT. MQTT has a lot of advantages because it has, for number one, it has encryption. Two, it's very friendly with remote locations. Instead of needing to be pinged like Modbus, it's just going to publish its data to a Modbus broker, an MQTT broker, as often as you program it to. And then anything subscribing to that MQTT broker can take that data and then use it. So very common, very popular, modern protocol. It can also respond to REST API GET requests. And so it has an open API, and it's very easy to ping the device with an API call and get the data either in an XML format or a JSON format. And you also have complete relay control with GET requests via the API. So there's a lot of flexible ways to get your sensor data out of our device and then do something with it. And you were talking about price points. So that's one of the other amazing things about control by web devices. They're essentially a PLC. They're a streamlined, sort of simplified, if this then that's logic PLC, and they're going to be anywhere from $300 to $600 a device. So again, you can take, if budget's a concern, you can take your APG ultrasonic, your X412 or X404 device, and have a pretty complete level measurement and control system under $1,000, as you mentioned.
One of the things I like is if you've got more than one tank or the need for more than one sensor, you can do multiple sensors per one of your devices.
Yeah.
Which is a big advantage.
Yeah, it's huge. And so our 404, that can monitor up to 32 Modbus devices. In this case, sensors. And they just daisy chain together, and they each have their address, and we've actually made it plug and play. So when you connect your Modbus APG sensor, APG specifically, this doesn't work with other brands of Modbus sensors, but with APG specifically, when you connect that device to our controller, in the controller, you're going to tell it what the sensor is, and it's going to automatically load the table's structure.
Which is so simple.
Yeah. So we make it incredibly easy. Yeah. So if you have a Modbus APG ultrasonic sensor, or even some of their other sensors, you can tie it right into our X404 and make it a lot easier on yourself. Now, 4 to 20 milliamp or even voltage signals, your analog signal group, very easy to set up. And so in our device, you're simply going to name it. You can name each one of the sensors, give it a custom name so they know exactly what they're looking at when they see it on their dashboard. And you're going to scale the signal, which is also very easy. And that's pretty much it. It's very straightforward. There's a couple different type options. There's some more detailed options. We can get into that. But it's very simple. So to kind of cover what a control by web controller can do, it's surprisingly capable. So a lot of people think of an I/O device like this as inherently simple. You might call it a dumb device, but these are actually very intelligent modern IoT devices. And so a couple cool features built in. So it is a networkable device. Everything on the device is completely embedded. So it's all the programming, the UI, everything's embedded on the device on an embedded web server. That's where the web comes in the name Control by Web. And that means I don't have to install anything on my computer. I don't have to worry whether it's compatible with my OS. Some of these industrial computers are quite old, so it's just really nice to have it just open your favorite browser and go to the device. They're each going to have an IP address, and I'm simply going to visit the IP address, log in, and it loads the streamlined browser-based UI. And I'm just going to go top to bottom. You have a menu on the left-hand side. I'm just going to go top to bottom, do my network settings, go through all the other setup. So simple IP, modern IoT device. So what can I do with it? I can send remote notifications as an email tool on there. I can send me emails when something happens, and there's a lot of tools to take that email and convert it to text or push notifications on your device. So there's a lot of ways to take that email and use it for more. It can email up to 8 people. You can email it to one forwarding address and send it out to as many people as you want. So it's a very flexible tool, having the email option. It also has embedded logic, and that's one of the neat things about a Control by Web device that other data acquisition units often don't have.
Right.
So I can go in there and with or without code. I don't have to touch code at all if I don't want to. And if I'm very comfortable with code, we use a programming language called BASIC that's very easy to learn. Code savvy people pick that up in a heartbeat. But I don't have to touch code if I don't want to, and I can simply set conditional logic. So if I have an empty application, if I've got a tank and I want to empty that tank when it gets too high. So once I get to a high level, I can turn on pump 1 maybe. Mm-hmm. Right? And once I get to my high level, my second, threshold, I can turn on a second pump. If I get even higher than that, then I'm turning on alarms. I'm turning the light stack red. I'm sending emails to people. I'm logging it. And so there's a lot of conditional logic built into the device. Again, it is completely independent of any other control system. So if my network goes down, it doesn't matter.
You're still good.
Everything's on the device and it's embedded.
You're not going to burn up any pumps.
No burning up the pumps. It's not dependent on a network connection. It's not dependent on a cloud or a SCADA connection. Now it can take its instructions from a SCADA or some kind of software. Absolutely, you can set it up to sort of be that remote device that just responds to the commands that it's given. And it can operate in that mode very happily.
It can also operate on its own.
It can also operate completely independently, yeah. And that's really part of what an edge device is. It's going to be at the edge layer that we talked about, but it means that it's not going to have any dependencies on any network connection. So in this case, I've got a cellular device here. If I've got a cellular connection on a remote tank, that cellular connection goes down. Well, really, it's that cellular connection is about communicating to the system what's going on. It doesn't have to be, and it's best practice not to, be pulling the commands, the logical commands from the software, from the remote software, the cloud, via that cellular connection. And that was a mistake that a lot of people made in the early days of, this IoT revolution. And everyone's kind of learned from that. We've moved on, but these devices ensure that you don't have any dependencies. So beyond logic, I can also data log. I mentioned that earlier. I can log up to once per second, and so I can just do an interval-based log. I can also do a conditional trigger-based log, and then I can get that log via FTP. I can have it emailed to me. I can use the Open API to ping the device, send a GET request to pull that log file as a JSON or an XML. A bunch of different ways to get your log file. Then it has the dashboard. It can act as a simple remote access device.
That was going to be my next question.
Yeah.
It's remote access to it to be able to see what your levels are if you're not on site.
Yeah, and so if I don't want to set up automated conditional logic, I can have a dashboard where I can simply click a button and turn the pump on. So it can be manual or automated control. So very, very capable devices. Setup's been extremely streamlined. We really worked hard to make this as easy as possible, and the reason we've done that is because a lot of the people working in the controls business are engineers with a lot of education and a lot of experience with programming, and this is easy for them. Super easy. So is, any other PLC and any kind of PLC programming language, whether that's ladder logic or structured text, or there's a few more. They know that world very well, but they're not the only ones who touch the control system. And a lot of our customers tell us, when my engineer goes out and they commission this thing, everything's working great. But then there's electricians and technicians and maintenance people that get involved, and all kinds of, and sometimes you can just have a tech-savvy business person who gets in there and is trying to get things done. So there's a lot of people who touch a control system, and so having the option of a streamlined user interface that doesn't require coding to work with it means that a lot of our customers are able to build a monitoring and control system with a tank and a pump and a valve, and then it doesn't get messed up when somebody comes in to troubleshoot it, or when somebody wants to tweak it, or whatever happens. So, or when that engineer leaves and they're no longer in control of the system. They can still
know what to do.
Yeah, they can get in there and figure it out.
It's easy. Yeah.
So that's one of the big advantages of these devices. So one of the other most useful features on a control by web device is they talk peer-to-peer natively. And they'll just do that over the network. So if they're on the same local area network, it's very easy. They'll just communicate directly to each other, no additional setup needed. They can also do it over we have a cloud backbone, and that's completely optional. Again, we talked about how they're not dependent on a cloud at all, and we developed a cloud to provide easier remote access and a data visualization tool, but it certainly isn't required, and that's one of the nice things about our device. When it comes to talking peer-to-peer, I could have a cellular device, over here, and let's say that's a couple miles away, and this 412 device, maybe this is sitting on a pump, somewhere, and this has Ethernet connection or some kind of Wi-Fi. These devices can talk to each other remotely via our cloud backbone as well. But at the end of the day, they communicate peer-to-peer natively, and it essentially creates a hive mind. I mean, they can all work together as if a single device. So I can pull all the I/O from one device over here. I guess this is the Modbus device. So I can pull all the relays and analog, into this one over here, or this one, since it has the relays on it, maybe it can pull the Modbus signal over in here and use that in its logic builder to make decisions and turn things on and off with its relays. And we have other devices that have relays. They've got digital inputs, just monitoring contact closures, temperature inputs. And so there's a couple different models that we have, and they all work together to create an independent standalone system. And honestly, that's a lot of customers take advantage of that.
Yeah.
A lot more customers still use this as just the intelligent field I/O, and all the data is going back to the larger control system. So again, it can operate in any way. So it can be a single device operating lone wolf, in conjunction with an ultrasonic sensor. You can have a simple system set up. Maybe you've got multiple tanks, you've got multiple sensors, multiple pumps, and it's out in the middle of West Texas or wherever. Then they can work peer-to-peer and create a simple system. Or it can just be, part of a huge system, and they're all just independent nodes of this much larger system that's going to include I/O modules from other manufacturers and all kinds of other PLCs, and it can operate in either mode and be very, very happy.
You kind of touched on some of the applications. Tell me a little about, what you guys see, some of the applications these are going into and how people are using them.
Yeah, so you talked about the water market. These are very common in the water market, so I'll give you an example. So we have a customer in Denison, Texas, and it's a water treatment facility there, and they use this as, where this is their edge device. This is where they're pulling all their I/O. So whether that's they have ultrasonic tank sensors, or sitting over an open channel. That's another way to use ultrasonics, right? They're monitoring those sensors. They also have other sensor technologies, radar, submersible pressure. They've got large water tanks. They've got small ones. They've got chlorine tanks with dosing pumps. So they're monitoring all these sensors, and then they're using the relays to do edge processing and control. So I've got a tank, and it's getting too full or it's getting too empty. They're just moving liquid around. They're also pulling in data from their water quality sensors, so turbidity, pH, the list goes on.
Yeah.
And that's going into their control system, their SCADA system, and their PLCs. And so it's sort of a mix with them. They're using some of them to effectuate control, on a tank over there with its pump and its valve. And others are just gathering the data.
A bridge, if you will, to their SCADA system.
Yeah, they act as a gateway, essentially, for the sensor into the network, into the control system. So that's a common way they're used. They're used in all kinds of things. We get into, building automation and security and all that kind of that other field. But in terms of level sensors, the water market's a big one. The oil and gas market.
It's a big one too.
Yep, I know you guys have hazardous location certifications. So you guys are sitting on oil tanks all the time. Our devices are not hazardous location certified, but they're often, just outside the hazardous zone with like an intrinsic safety barrier. So they're used in that way pretty often. But they're also used on water in the oil and gas field, because the other major product in oil and gas is water, and it gets consumed. It doesn't get produced. There's waste streams, and they handle that. But water's a big deal in the oil and gas industry, and so they're sitting on water tanks or in the control cabinet next to the water tank. Yeah, so very common, and they're used to take sensor signals from all over. So you can have a flow meter and a level sensor and a temperature monitor. All these different sensors on a site, and they all need to come in somewhere together and then be processed or be passed further up the chain.
We've talked about a lot of things with the sensor and with your control devices today, but one of the things I like the most is the simplicity of the whole system, right? I mean, the sensor is very simple, it's very straightforward. The control device can be very simple, very straightforward in how you program it and how you set it up. If you want to get into the details of it, if you want to dive in and you want to fine-tune it to your application, you can do that, and you can get into the programming, which is I love it. It's very simple, but you can get in and you can customize it as well.
There's complexity there. We can handle it. You can dive deep, but you can also just deploy a system and have it up and running in an afternoon and be done.
Yeah,
which is beautiful.
Which is awesome.
Well, thank you, Shaw. APG is a great company, like us, made in America. We are too. In both cases, we're designed, manufactured, sold, and serviced, and the service is a really big deal, under the same roof here in America. And so you can buy the technology, you can buy the sensor, buy the controller, get out there in the field, and there's someone waiting for you on the other end of the phone to get you through that installation, get you through that troubleshooting. It can go very smoothly, and it does all the time. We all know it can also, it can go wrong.
It can hiccup a little bit.
It can hiccup, right? And there's a lot of reasons why that happens, but the support team in both cases is going to be there for you. Very easy to get a hold of us.
And they're actually real people.
Real people, and they're here, and it's just so much easier to do business that way. Again, APG, they've got some models on the shelf ready to go. A lot of it's built to order because there's a lot of customization that goes into play with sensors specifically. With controllers, it's honestly a simpler device than the sensor in a lot of ways. These are on the shelf, ready to ship, same day. If you order before 3 p.m. Mountain Time. Yeah. So very, very easy to get these ordered and get them on site. No, logistical issues or supply chain. Hiccups going on right now. So these are very easy to get. We love working with Automation Products Group, and I hope.
We love working with you guys too. You're a great company to work with.
Yeah, so thank you. Thank you very much. Appreciate your time in explaining ultrasonic technology and
Thanks for having us.
Yeah, how it can really simplify. Yeah. Which is, we're big on that. We're big on simplifying complex things. Thank you, Shaw.
You bet. Thank you.